Hello everyone, thank you for joining our midterm demo. Today, we have two team members to participate in this presentation. My name is Daniel, and I will be introducing the What We Achieved section. Shiyu will be covering the What We Learned and the Next Steps sections. Now, let's start with the core features we've successfully implemented so far. In this section, we've completed the following key features: third-party login, stay signed in, reset password, email verification, integration with Exchange, and internationalization support. First, let's talk about our integration of third-party login using Google Auth. What is Google Auth? Google Auth allows us to log in using the existing Google account, so they don't need to create a new username and password just for our app. How does it work? The user clicks the login with Google button on our login page. Start with the OAuth process. Our app asks Google for permission to access the user's basic profile information. Google shows a screen where the user can allow or deny this access. If the user agrees, Google sends an authorization code to our app. We then exchange this code for an access token. This access token is used to retrieve the user's profile information. Once the access token is validated, the user is logged in and their Google account information is securely passed to our application. Why is this important? This integration makes the login process easier for users and improves security by using Google's trusted authentication system. Okay, next, let's discuss the stay signed in feature, which is important for user convenience and security. How does it work? When a user logs in, our backend generates two tokens, an access token and a refresh token. The access token is short-lived and is used for all following requests. The refresh token lasts longer and is used to get new access token when needed. The access token is stored in the user's browser cookies, while the refresh token is stored on the web server. Each time the user makes a request, the access token is sent to our backend to verify. If the access token is valid, the refresh request proceeds as normal. If it's not valid, our backend checks the refresh token. If the refresh token is valid, a new access token is generated and sent to the user. The front end catches this new cage token and updates the cookies, keeping the user signed in. If the refresh token is also not valid, the user is logged out and asked to log in again. So why is this beneficial? This feature allows users to stay signed in login without needing to re-enter their credentials, making the experience smoother and more user-friendly while ensuring security. Okay, finally, let me walk you through our streamlined reset password process. How does it work? If a user forgets their password, they can start the reset process by clicking the Forgot Password link. They are directed to a page where they enter their email address. Our system checks if the email is linked to an account. If the email is valid, a secure link is sent to the user's email. If not, they are asked to try again. The user clicks the secure link in their email. It brings them back to our app. They enter and confirm a new password. The system updates the password and logs the user in automatically. A confirmation page is displayed, showing that the password reset was successful. So why is this process effective? It ensures that users can quickly regain access to their accounts if they forget their password, while keeping the process secure with email verification. Now, let's discuss the challenges we face with our old front end and how we resolve them with the Turbo framework. So, we met some challenges, legacy issues. When we migrated from React to Next.js, we encountered bugs and inefficiencies, especially in how the app handled client-side and server-side rendering. The old system was too complicated with too many layers, which made the code hard to maintain and slowed down development performance. We faced issues like page flickering and inconsistent preloading, which negatively affected the user experience. Using styled components led to much CSS, making it difficult to maintain a consistent design across the app. So how Turbo solved these problems? Simplified architecture. Turbo helped us better organize the code, clearly separating client-side and server-side logic, reducing bugs and making it easier to manage. Streamlined structure. We simplified the code by reducing necessary layers, making it cleaner and easier to work with. Improved performance. Turbo optimized how components are rendered and preloaded, fixing the flickering issue and ensuring content loads smoothly. Better styling. Switching to Tailwind CSS reduced excess CSS and allows us to create a more constant design. We also built a Tailwind-based component library, which sped up development and improved the user's interface. In summary, by adapting Turbo, we've transformed our front end into a system that is easier to maintain, more scalable, and better performing. This changes not only resolve issues from our previous architecture, but also set a strong foundation for future growth. Lastly, we've resolved several key bugs, including enhancing user feedback with a loading bar during registration, fix a 404 error on the dashboard, standardizing UI components, correcting validation logic, improving SEO with dynamic titles, and fixing sidebar icon rendering issues. In summary, we've made a significant process in implementing core features and optimizing our front-end architecture. These improvements enhance the user experience and lay a strong foundation for user development. Next, I'm pleased to invite Shiyu to share more with you. Thank you.
Good. So let me share screen. Okay, can you guys see my screen? Oops. We'll just tap. Yeah, okay. We can see my screen. In our first demo, we introduced the core technologies powering our project: Next.js for the front end, and SJS for the back end, and GraphQL as our API layer, and Postgres SQL for our database. We also utilized the TypeScript to ensure strong data typing across the stack. Additionally, we use React testing library for front-end testing and Jest for back-end testing. The development process has been incredibly enriching, allow us to dive deep into these technologies and put into practice many important concepts. However, given the time constraints, I have decided to focus on a few specific areas that I believe are particularly worth sharing. So as you might know, Next.js utilizes a file-based routing system, which makes it easy to organize and manage our application structure. It also allows us to categorize rendering into client-side rendering and server-side rendering. When refactoring our front-end code, we took advantages of this modularity to ensure a clean and organized code base. For instance, we made sure that only the necessary files were including apps file directly, eliminating any unused or redundant files. This approach improves maintainability and clarity of our applications. Additionally, we have categorized client-side and server-side behaviors to ensure a clean separations of concerns. For instance, in our logging files, we made sure that all client-side logic, such as hooks, handle entirely on the client side. This includes everything related to user interactions and UI updates. On the other hand, backend interactions such as the login servers, error handlings, and any requests sent to the server are placed in a separate file. It dedicates to server-side logic. While these separations not only improves the code reliabilities and maintainabilities, but also ensure that each part of the applications is performing optimally in its respective environment. Okay, next is about Tailwind, which I'm sure many of you are already familiar with. I mainly want to introduce the use of CVA and CLSX, well, as shown below. These reusable buttons components created in our project using CVAs. With CVAs, we can easily define the and manage different style, size, and variants for our components. On the right, you can see simple examples of how CVA is used in a TSX or JSX files. The code demonstrates how to create style variants and apply them dynamically in a React component, making the styling process more efficient and maintainable. So for CLSX, it's particularly useful when you need to apply style conditionally based on certain props or states. It allows you to dynamically combine class names and in a clean and efficient manner, which simplifies your codes and makes it more readable. As you can see in the code example on the slides, I'm using CLSX to conditionally apply style to the button. The button class variables is defined using CLSX, where we apply base styles like paddings and rounded corners. Then depends on its primary and its disabled conditions, additional styles are applied. Such as a blue background for primary buttons or a gray background with disabled cursors for disabled buttons. So together, these tools enhance the flexibilities and maintainabilities of your code, allowing you to build sophisticated and responsible UIs with greater efficiencies. By integrating CLSX and CVA into our Tailwind workflow. We have streamlined our styling process and creates a more organized and scalable code base. So Customizing the color palettes in Tailwind CSS offers significant advantages, particularly in terms of brandings and maintainabilities. By defining custom color palettes, we ensure that our applications maintains a consistent look and feel that aligns perfectly with our brand identities. This consistency is crucial for our user experience as it reinforces brand recognitions and makes the interface more comprehensive. And centralization, our color definitions in the Tailwind configurations files makes it incredibly easy to update and manage our color scheme across the entire project. If we ever need to adjust a color, we can do so in one place, and those changes will automatically propagate throughout the applications, maintaining consistencies and reducing the risk of errors. So as you can see on the right, that's a simple example of customizing color palette. For instance, our primary colors are based on modified versions of the blue-gray palettes. The accent colors are customized shades of pink and red, adding vibrancies where needed. So below there, you can see how these customized colors are applied to components by using the centralized color classes like BG primary 100s or text accent 500s. So we can easily maintain consistently across all of our UI elements. This approach not only simplifies the development of also makes future updates design system much more manageable. Next, so let's dive into React Hook Form and how it simplifies form management in React applications. So the first thing I want to mention is the easy validations. React Hook Form simplifies form validations by requiring minimal code, as you can see in the example on the right. We can easily validate files like usernames and passwords by using the register functions. The validation rules are straightforward, and error messages are handled seamlessly, making the code easy to read and maintain. And another key strength of React Hook Form is the ability to minimize re-renders. By managing form states efficiently, it ensures that only the necessary components are rendered when there are changes. This leads to better performances, and especially in larger forms. So in the code example, you can see how simple it is to set up a form with validations using React Hook Form. So so I also wanted to talk about I18N and Next Intel, which is one of the library of the I18N. So I18N is essential for making our app accessible to a global audience, allowing users to interact with the interface in their preferred language. So as you can see on the right, these are actual screenshots from our project demonstrating how our application can seamlessly switch in between the English and Chinese. This has been implemented using translation files managed by robots I18N libraries like Next Intel. Allows us to dynamically load and appropriate language contents based on the user preferences. So these implementations not only just borders our applications accessibilities, but also prepare us for the future growth. Adding new languages is simple, making it easier to expand our reach as we scale the abilities. So come to the our end of the section. Our next steps. We will focus on the developing the following key features, such as market data integrations. So we will establish connections with the virtual currencies market, enabling the retrieval, secure storage, and real-time rendering of market